The science behind global warming. Global warming refers to the long-term increase in Earth's average surface temperature primarily due to human activities that release greenhouse gases into the atmosphere. This phenomenon has significant implications for climate patterns, ecosystems, and human societies. Here's an overview of the science behind global warming. Greenhouse effect. The greenhouse effect is a natural process where certain gases in Earth's atmosphere, such as carbon dioxide, methane, and water vapor, trap heat from the sun. This trapped heat warms the planet's surface to a comfortable average temperature of about 15 degrees Celsius, 59 degrees Fahrenheit, supporting life as we know it. Enhanced greenhouse effect. Human activities, such as burning fossil fuels, coal, oil, and natural gas, for energy, deforestation, and industrial processes, have increased the concentration of greenhouse gases in the atmosphere. This enhanced greenhouse effect intensifies the trapping of heat, leading to global warming. Carbon dioxide, CO2, emissions. Carbon dioxide is the primary greenhouse gas emitted by human activities, primarily through the combustion of fossil fuels for transportation, electricity generation, and heating. Deforestation and land use changes also contribute to increased CO2 levels. Methane, CH4, and nitrous oxide, N2O. Methane and nitrous oxide are potent greenhouse gases emitted from agricultural activities, such as livestock digestion and rice cultivation, landfills, and industrial processes. While they exist in lower concentrations than CO2, they have a much higher heat-trapping potential. Temperature trends. Scientific observations show that Earth's average surface temperature has increased by about 1.2 degrees Celsius, 2.2 degrees Fahrenheit, since the late 19th century. This warming trend is evident in rising global temperatures, warming oceans, melting polar ice caps and glaciers, and shifting climate patterns. Climate feedbacks. Global warming triggers feedback mechanisms that amplify its effects. For example, as Arctic ice melts, it reduces the planet's reflectivity, albedo, allowing more sunlight to be absorbed by the darker ocean surface, further warming the region. Impacts on weather patterns. Global warming alters weather patterns, leading to more frequent and intense heat waves, droughts, wildfires, and heavy rainfall events. These changes have profound implications for agriculture, water resources, and human health. Sea level rise. Melting glaciers and ice sheets, along with the thermal expansion of seawater due to warming, contribute to sea level rise. This phenomenon threatens coastal communities with increased flooding, erosion, and saltwater intrusion into freshwater sources. Mitigation and adaptation. Addressing global warming requires mitigation efforts to reduce greenhouse gas emissions through cleaner energy sources, energy efficiency, and sustainable land use practices. Adaptation strategies focus on building resilience to climate impacts and preparing communities for inevitable changes. International agreements. The Paris Agreement, adopted in 2015 by nearly 200 countries, aims to limit global warming to well below 2 degrees Celsius, 3.6 degrees Fahrenheit, above pre-industrial levels, with efforts to pursue a more ambitious target of 1.5 degrees Celsius, 2.7 degrees Fahrenheit. International cooperation is essential for achieving these goals. Understanding the science behind global warming is crucial for informed decision-making and collective action to mitigate its impacts and safeguard the planet for future generations. Continued research, policy initiatives, and individual efforts are vital in addressing this global challenge.